Welcome to UC Science Radio, where we conduct interviews with a range of scientists to learn about the big issues facing our world and what science is doing to help. I'm Molly McGidd, a master's student in the School of Biological Sciences.
Today, I'm talking with Dr. Chris Gordon. He's a senior lecturer of physics at UC, specializing in high-energy astrophysics and cosmology. He's spent much of his career studying dark matter, the unseen substance that makes up the majority of our universe, but remains a mystery to science. Welcome, Chris. Kiora, to start, what do you do and what's your research?
Well, thanks for having me on here. It's very nice speaking to you about my work. So I'm a senior lecturer at the University of Canterbury, and I'm mainly interested in an area known as dark matter. It's part of cosmology, which is where we're studying the whole universe. And we think that there is this very unusual type of matter, which is actually more numerous than ordinary atoms that we're familiar with. The only thing is it doesn't seem to interact with light or ordinary matter except gravitationally. So, even if we were having dark matter passing through us right now, we wouldn't notice it. It's only when you look at the way galaxies rotate or other large-scale motions in the universe, you can really see that there is something else there from the gravitational attraction that's been felt by the ordinary matter and light.
So you're saying it's not visible in ways that we might see other things in the universe, but the way that other things in the universe react, it shows there is this thing called dark matter out there.
Yes, exactly. Yeah, because usually when we look at a object, it's basically we're seeing the light which is reflected off that object. But with dark matter, the light will simply pass straight through it. So the only way we can see it is the fact that, we can see that things like galaxies are attracted towards something, even though there's no light being reflected from that thing. So we assume there's some kind of matter there which doesn't interact with light.
And you said that it does have some sort of gravitational effect. So what are the ways that you can discover that effect or find out where this dark matter is?
Yes, so one of the first ways they were becoming aware of this dark matter was when they looked at how galaxies were rotating. It's like when you have a weight at the end of a string and you, say, spin it around your head, you can feel that weight pulling on the string, and the faster you spin it, the greater that pull is. And so similarly, when you have a galaxy rotating, it needs something to stop it flying off, just like that weight would fly off when you spun it round. And so usually we think, oh, well, it's the gravity of the stars in the galaxy which stop the other stars flying off. But then when we see how fast the galaxy is rotating and we work out how strong that gravitational pull would be if it was just the stars, because the gravitational pull is proportional to the amount of matter there. And so then we see, those stars would not be sufficient to have that galaxy spinning so fast. It should be flying apart. So there must be some other material in there who's providing that extra needed gravity.
So what devices or procedures or things do you do in your lab to quantify this dark matter, or when you're searching for it?
Yeah, so I'm interested in a particular idea that maybe this dark matter is not only interacting gravitationally, perhaps there are some other types of interactions it very rarely undergoes. So it's possible, for example, that if this dark matter is made up of particles, sometimes two of those particles could collide with each other. And, perhaps when they collided with each other, they could produce some ordinary matter or ordinary light. there are some theories which predict that. And so what I've been hoping to do then is look in areas of the universe where we can tell there must be a lot of this dark matter due to its gravitational attraction that's causing there, and then check, is there any extra sources of light or matter being created in that area of the universe, which could come from these dark matter particles colliding with each other.
So searching for the light they may produce during that collision.
Yeah, the particular ones that I've been interested in recently is one of the more popular theories of dark matter was that the particles would be so heavy that when they collided with each other, they wouldn't produce ordinary light. They would produce light with a very high frequency known as gamma rays. So I've been particularly interested in looking at gamma ray observations and seeing in areas where we infer there must be a lot of dark matter, do we see gamma rays coming from those areas which we can't explain by any other cause?
How do you think research on the universe can influence what we do and think on Earth? People may say, what you're looking at is so distant from us, but how can, just the normal person off the street be influenced by that research?
Yeah, that's a good question. And I think with a lot of this very kind of cutting edge, high energy physics, often there is quite a lot of spin-off benefits because the experimental techniques that they have to develop will often really push technology much further, because we have to really, increase precision and look at new ways of probing aspects of nature. And so that always means there has to be some technological development to facilitate that. So I think those technological spin-offs do then make their way, into the rest of the world, which then finds some more practical uses. So the famous example is, if you think of the World Wide Web, that was actually developed by someone at CERN, which is, where they have the big particle accelerator in Switzerland. And then also another example is Wi-Fi was developed by radio astronomers when they were setting up their experiments. So there's lots of technological spin-offs like that, which come from this research, which seems disconnected from everyday life, but then does end up having some benefits.
Yeah, that's really important, especially right now. I think everyone is glad that Wi-Fi exists and that the World Wide Web exists. So
it's definitely making lockdown a lot easier, yes.
So what was your path to this research and to your position? Like, how did you get interested in this?
So I did my PhD in cosmology. That was back in the UK. And then I was really, when I initially did my PhD, I was more interested in another area of cosmology, which was to do with the beginning of the universe. But then I got a little frustrated with that area because there didn't seem to be enough new data available for us to really improve the understanding further than what had already been gained. And so I looked around to see what were the other areas which looked like there may be more data available and more promise of, making some progress in understanding that aspect of cosmology better. And so dark matter seemed to me quite a good one, because there are basically a lot of experiments currently being done which have the hope of shedding more light on that particular puzzle of what are these dark matter particles.
Do you have any people who really inspired you to do this work or continue to inspire you?
Yes, when I was at high school, I really loved reading popular science books and also watching, popular science shows. And so those really inspired me a lot, because it allowed me to get some reasonable understanding of the current state of the knowledge without, having all the mathematical background that's needed to, fully understand it.
So, like, one that I think of is Carl Sagan with Cosmos, like a sort of science communicator.
Yeah, I really enjoyed Carl Sagan, and yeah, I remember reading, like Stephen Hawking's popular science book as well. That was very inspiring. Although I don't think I understood too much of it at the time, it still got me very kind of interested to try and learn more.
What is the most fun or exciting part of your work?
For me, I think I really enjoy learning a lot more about areas of physics and astrophysics or astronomy that I hadn't known that much about before. So when I'm doing the research, I do like to, try and produce some useful new knowledge. And that's great, if I find some really good result, which is a big help to, increase the understanding. But often I'm also enjoying having to learn about some new aspects of physics or statistics or astrophysics while I'm doing the research.
It's nice to know that professors aren't already coming into the role knowing everything and are, still learning every day, because as a student it can seem like, oh, they just know everything, but it's good to know you're continuing to research and learn new things.
Yes, there's just so much knowledge out there. I think everyone kind of can be quite knowledgeable in one specific area, but then, depending on the kind of research they're doing, if they could be focusing in on a very narrow area where they may kind of have all the background they need. But often, if one's trying to move into some new aspects, then there's always going to be huge amounts of stuff that needs to be learned to do that.
What's next for you? Something new that you're working on, or a project that you're excited to start?
Yeah, so I've become more interested in a type of star known as a neutron star. And so initially, one of the problems with looking for dark matter producing gamma rays, say by dark matter particles colliding, is that it's quite hard to distinguish that from these neutron stars because they also produce gamma rays. And so I've needed to try and understand those neutron stars better. And my main motivation initially was to try and see if there was some way of distinguishing the gamma rays we see from the gamma rays that they would produce. But unfortunately, so far, it seems like the excess gamma rays we were hoping were dark matter are actually being produced by these neutron stars. But now I am quite keen to try and see if, because these neutron stars are very dense objects and they have sort of very extreme physics going on around them in terms of very high magnetic fields and electric fields. So I'm quite keen to see if that extreme environment could help us maybe probe dark matter a bit better if the dark matter was being affected by that very extreme environment. So that's one area I'm hoping to try and go into some more.
Great. So my last question is, in one sentence, if you could say why your work is so important.
Well, the dark matter is 5 times more numerous than ordinary matter. And so I am trying to help figure out exactly what it is. That would, I think it'll just be very good for our understanding to know what all this stuff is out there.
Right? If you're looking for something that is the majority of the universe, that seems
Exactly.
like a pretty big deal.
Yeah, I think so, yeah.
Yeah. So thank you so much for your time. I really enjoyed talking to you.
It was great speaking to you. Thanks for arranging it.
That's it for today. For more information or to ask a question about any of the ideas raised in this show, feel free to send UC Science a message by email, Facebook, or Instagram. Thanks for listening.